So we're going to be looking at more trigonometric functions today, and just how to use trigonometric functions, properties of trigonometric functions, and different real-world applications of them. I'm still a little sick, so if I'm coughing a little bit in the video, I apologize. It's going to happen though. Here we go, right off the bat. All right, so let's look first at what are some trig identities. Well, some of them you already know. We call some of them the reciprocal identities, and essentially all the reciprocal identities are the ones with where we know that the cosecant of theta is going to be 1 over sine theta, right? We talked about how sine is y and cosecant is 1 over y, right? So it's just you flip it upside down or put 1 divided by sine to get cosecant. And same thing with secant. Secant is 1 divided by cosine, and cotangent is 1 divided by tangent. And this goes the opposite way also. Sine of theta is also 1 divided by cosecant, and cosine is 1 divided by secant, and tangent is 1 divided by cotangent. So those are your reciprocal identities. The cofunction identities, just are identities that kind of go along with sine and cosine. So essentially what this tells you is if you want to know what the sine of 90 minus theta, okay, so whatever your angle is, if you take it away from 90, then that's going to equal the cosine of theta. Alright, so the sine of 90 degrees minus your theta is going to be equal to the cosine of theta. And vice versa. Cosine of 90 minus theta equals the sine of theta. So essentially what that's saying is, like, let's say the angle was 60. So sine of 60 is going to be the same as the cosine of 30. The sine of 30 is the same as the cosine of 60, and vice versa. And that also is going to apply to secant and cosecant, and tangent and cotangent. So the secant of 90 minus theta equals the cosecant of theta, and the cotangent of 90 minus theta equals the tangent of theta. Okay, so those are always going to be true. If you take the tangent of 20, that's the same as cotangent of 70. If you take the secant of 10, it's the same as the cosecant of 80. So that's always the case with those trig functions. Now the quotient functions. Excuse me, sorry. The quotient functions are pretty basic. We know that the tangent of theta is always the sine of theta divided by the cosine of theta. And since cotangent is just the flip of tangent, the cotangent is the cosine of theta divided by the sine of theta. Okay, we call those the quotient identities, but we use those a lot when we're doing things with properties of trig functions. Okay, last ones that we'll look at are called the Pythagorean identities, and the main one that you use for these is that sine squared of theta plus cosine squared of theta equals 1. That's the main one that you're going to see used. Sine squared of theta plus cosine squared of theta equals 1. And yes, sine squared of theta, all that is sine theta times sine theta. It's sine theta times itself. All right, so sine squared theta is just sine times sine. The other ones are 1 plus tangent squared of theta equals secant squared theta. And 1 plus cotangent squared of theta equals the cosecant squared theta. Alright, so those are the Pythagorean identities. And you're like, what is all this stuff for? We'll get to that here in a second. Right, so let's look at a problem right here. And we're going to use these identities to do these problems. So it says, let theta be an acute angle such that the cosine of theta equals 0.8. And we want to find the values of sine and tangent using our trig identities. All right, so one way we can do that is by using, we know cosine, so we can plug that into one of these functions. So let's say we use this one right here, sine squared plus cosine squared equals 1. So we know cosine is 0.8. So we're going to say, all right, well, let's plug that in. So sine squared of theta equals cosine, or sorry, plus the cosine squared. Well, the cosine is 0.8 squared is going to equal 1. All right, so we've got sine squared plus 0.8 squared is 0.64. Subtract 0.64. So we get 0.36. Now you take the square root to get sine by itself. So we've got sine theta equals whatever the square root of 0.36 is, that's going to give us 0.6. So there we go. We wanted to find what sine theta. Sine theta is 0.6. And if you wanted to make that a fraction, you can make it into 3/5 if you want. So there's sine theta. Well, now once we know sine theta, we can use our quotient identity, this one right here, to find tangent. Because tangent is just sine divided by cosine. So we found sine is 0.6. So tangent theta is going to be sine 0.6 divided by cosine 0.8. We already knew cosine was 0.8. So that means tangent of theta is 3/4 or 0.75. Either way you want to do it. So there's an example of how you can use those. Okay, use the trig functions, plug something in, see if you can solve. There's more than one way to do a lot of these, okay? So don't feel like you're fixed on just one way. The important thing is to find a way that works and get the right answer. So you go ahead and try the one down here. Let me know if you need any help, and I'll come by and help you. We know tangent of theta is 3. We want to find the cotangent and the secant. Well, we can find the cotangent really easy because tangent and cotangent are one of the reciprocal identities. So go right here, cotangent is just 1 divided by whatever the tangent is. So we know the tangent's 3, and cotangent's 1 divided by 3. Second one, to find secant. We need to try to figure out which one of these identities uses secant and tangent together. And you can see that's one of our Pythagorean identities. 1 plus tangent squared equals secant squared. So we plug in our values in for it. So tangent theta is 3. So we do 1 plus 3 squared, since tangent is 3, equals the secant squared. 3 squared is 9, plus 1 is 10. And then to get secant by itself, we take the square root of both sides. So secant theta is the square root of 10. So there's an example of how we can use those identities. A lot of times you just got to find an identity that uses the two trig functions you're working with. We have tangent, we want to find secant. So we look up here and see, oh, well, this Pythagorean identity has tangent and secant in it, so we'll use that one. On this one, we said we had cosine and we needed to find sine. So we look for the one that has cosine and sine in the same thing, and we use that trig identity to find the cosine, or the sine of theta. Let's go on and do some more of these. Now, so we want to use the identities to transform one side of the equation into the other. I should say into the other, not in the other. So we want to change one side of the equation to look like the other side. So for this first one, we've got cosine theta times secant theta equals 1. So what identity can we use? One thing that I like to do on these guys is change everything to be sines and cosines. So every trig identity, or every trig function, can be written as sines and cosines. Tangent can be written as sine over cosine. Cotangent, of course, is cosine over sine. Those are our quotient identities. But then the other two, secant and cosecant, you can write those as either 1 over sine or 1 over cosine. So when you're trying to do some of these identities right here and show that one thing equals another, a lot of times the easiest thing to do is just make everything that's not a sine or a cosine into into terms of sine and cosine. So for this first one, we've got a cosine and a secant. Well, secant, that's not a sine or cosine. So let's change it using the identity to make it into either sine or cosine. We know from our last slide that secant is 1 over cosine. That's one of our reciprocal identities. So we can change secant to be 1 over cosine theta. Okay, so now I've got cosine theta over 1 times 1 over cosine theta. Something, when we multiply fractions, top times top, and bottom times bottom. So I get cosine theta over cosine theta. Well, that's something divided by itself, which is 1. There you go. So I showed that cosine theta times secant of theta is going to equal 1, because secant theta is just 1 over cosine. All right, let's do another one here. So on this one, before I change everything, I need to get rid of all the parentheses. I just want to multiply everything out, get rid of all that stuff, and that'll help me out a little bit. So let's multiply by doing distributive property. Secant times secant, well, that's secant squared theta. And then I've got secant times tangent, negative tangent, so that's negative tangent theta secant theta. And tangent times secant, that's positive tangent theta secant theta. And then tangent times tangent is negative tangent squared theta. Alright, so these two in the middle are going to cancel. We got negative tangent secant plus tangent secant. So those two just cancel out. And I'm left with secant squared theta minus tangent squared theta. And I want to make that equal 1. Right? So I'm going to show that left side equals 1. So now what can we do? Well, remember we have a Pythagorean identity that says 1 plus tangent squared equals secant squared. So I can go back right here and replace, I can replace this secant squared with 1 plus tangent squared, because those are equal to each other, right? 1 plus tangent squared is secant squared. So whenever I change secant squared into 1 plus tangent squared theta, not equals minus, and then I have minus tangent squared theta, well, the tangent squared and the minus tangent squared just cancel out, and I'm just left with 1 equals 1. And I've shown that secant theta plus tangent theta times secant theta minus tangent theta equals 1. Right, I know it's a little complicated. It's kind of like a puzzle. You got to try some things, try a piece, see if it fits. If it doesn't, try another piece, see if it fits, and just try to get it to work out, right? So go ahead and pause it and try the next ones, and let me know if you need help. I'll come around and help you. And if not, I'll explain how to do it in a second. All right, so on this first one, of course, you need to distribute. So we go ahead and take care of the distributing. And whenever we do that, we get cosine theta and minus cosine theta that cancel. So on the left, we just have 1 minus cosine squared equals sine squared. So it's pretty obvious which identity we need to use from here. It's the one that has sine squared and cosine squared in it, one of our Pythagorean identities. So if we just replace the 1, let me highlight it here real quick. If we just replace the 1 with sine squared plus cosine squared, right? Because looking at back at our identities, sine squared plus cosine squared equals 1, right? Under the very first Pythagorean identity. So we can change that 1 to be sine squared plus cosine squared. Now once we have sine squared plus cosine squared, our cosine squareds will cancel out because we've got cosine squared minus cosine squared. So those cancel out and we're just left with the sine squared on the left. So now both sides of the equation are sine squared theta. Now B I didn't do yet because I'm going to show you how to do it. It's a little bit trickier. We've got these fractions. So notice on the left side we have 2 fractions added together. But on the right side it's just combined into one thing. So our goal, that should give us a hint that we need to combine those 2 fractions into one thing. Well, in order to add fractions, they have to have a common denominator. So right here, one denominator is cosine, one of them is sine. So that means on the bottom of the left fraction, we need to give it a sine theta. And we need to give the bottom, the fraction on the right, the bottom a cosine theta. That way, they'll have the same thing on the bottom. So I give the bottom left one a sine theta to go along with the cosine. And I give the bottom right fraction a cosine theta to go along with the cosine theta on the left. But the thing is, you can't just give the bottom of a fraction something, right? We do this same thing when we're doing fractions with numbers, and you can write this to the side if you want. If I have like 1/2 and I want to add it to 1/3. Okay, so what we do is we say, all right, we'll multiply the 2 by 3 and the 3 by 2, That way the denominator is both 6, right? But if we do that, it changes the value of the fractions. It makes one fraction 1/6 and the other fraction 1/6. And that's not the value of the real fractions. They're a half and a third. So we also multiply the tops by 3 and this top by 2. So the top up here is now 3 and the top on this one's 2. Then we can add them and say, all right, 3 plus 2 is 5, and the denominator stays 6, and it's 5/6. 3, 6, and 2, 6 is 5/6. So that's the same thing we're doing. What we did, instead of multiplying the 2 by 3, we multiplied the cosine right here by a sine, and we multiplied the sine by a cosine. So we did the exact same thing, only instead of doing it with numbers, we did it with trig functions. So since we multiply the bottoms, we've got to multiply the tops by the same thing. So on the bottom left fraction, we multiply by sine theta. So we've got to multiply the top by sine theta, which sine times sine is going to give us sine squared theta. And then on the right fraction, we multiply the denominator by cosine, so we've got to multiply its numerator by cosine, which makes it cosine squared. All right, then on the left we still have cosecant theta times secant theta. All right, now we can combine those fractions into one, just like I did with the 2/6 and 3/6, because now they have a same denominator. So up top I can say, all right, well, sine squared theta plus cosine squared theta over sine theta cosine theta is going to equal cosecant theta secant theta. Remember, my whole goal here is to make both sides look the same. Now you need to use the identity. Up top you see sine squared plus cosine squared. Well, just like the last problem, that's one of our trig identities. Sine squared plus cosine squared is just 1. So we can just change that to be 1. So we got 1 over sine theta cosine theta equals cosecant theta secant theta. All right, now the last thing you need to do is just use your reciprocal identity. The knowledge that cosecant's 1 over sine and secant's 1 over cosine. So we just use that to flip our fraction. So it's all right, well, 1 over sine, that's cosecant, and 1 over cosine, that's secant. So we see that cosecant theta times secant theta equals cosecant theta times secant theta, and we're done. All right, so again, the clue right there was that you had 2 fractions on the left and only one thing on the right, so you needed to combine those together. So you need to have common denominators. Right? I want to make sure you guys saw one like that. If you didn't get it by yourself, I understand it's a little tough, but now you'll know how to do ones like that with fractions now. All right, let's go on and look at some real-life problems using trig functions. All right, so a surveyor is standing 50 feet from the base of a large tree, and the surveyor measures the angle of elevation to the top of the tree, 71.5 degrees. How tall is the tree? So on a problem like this, easiest thing to do is draw a picture. So we've got a tree, pretty blue tree. We've got a surveyor dude standing out here, and he's measuring, says he is standing 50 feet from the base. So this is 50. And he measures an angle of elevation to the top of the tree. So this angle in here that he looks up at, right, is 71.5 degrees. All right, so it's 71.5 degrees. And the question is, how tall is the tree? So we call this over here X. All right, so what you want to do is use your knowledge of SOHCAHTOA. All right, so we're going to remember the word SOHCAHTOA, and you all probably did problems like this in geometry. All right, so we need to determine, do we have the opposite side and the hypotenuse that we need to find? Is it the adjacent and the hypotenuse, or the opposite and adjacent? So my 90-degree angle is right here at the tree. The side across from 90 is your hypotenuse. All right. The side across from the angle you're using, that's your opposite side. And then the other side is the adjacent side. So we know the adjacent side, and we want to find the opposite side. So which trig function is O and A? Well, that's T. T for tangent, right? So that's how we identify whether we use sine, cosine, or tangent. Is based off of which of the 3 sides we're using, opposite, hypotenuse, or adjacent. So since we're using opposite and adjacent, we've got to use tangent. So you do tangent of the angle, it's always the angle, 71.5 degrees, equals, and tangent is opposite over adjacent. So opposite is X over, and adjacent is 50. Now to solve this, we just need to get X by itself, so it's X divided by 50. So we need to times both sides by 50. So we got x on the right. Then our calculator, we're just going to do 50 times the tangent of 71.5. Now, since you're doing degrees, you need to hit the mode button. Okay, it's the one right beside the blue second button. You hit the mode button and go down and make sure you turn it to degrees. It's the third line down. It says radian and degree. Since we're typing in the trig function of a degree, we need to select degree right there. So we're going to hit 50 and then your tan button, 71.5, and hit enter, and it'll give you your answer of 149.43. Alright, so you can round it. It depends on what the directions say, just as how tall is the tree. So we could say it's about 149 feet. Alright, you can get exact and say 149.43 or whatever you want to round to. Alright, so that's the height of our tree, which is reasonable, right? If you get a negative number or you get something like, 20,000, then you know you must have done something wrong because there's no tree that's 20,000 feet tall on Earth that we know of. So let's let you guys try one down here, give it a try, I'll go over it, and let me know if you have any questions. So here's a picture of the skateboard ramp. We've got the angle of elevation of 18.4 degrees, and we've got the height of the ramp is 4 feet off the ground, and they want to know what's the length of the ramp. So that's the x this time is up here you can see as our hypotenuse. So this is our hypotenuse, 4 is the opposite side, and then 18.4 is our degree, and of course the side down here that we're not using is adjacent. So which trig function do we need to use? So using SOHCAHTOA, right, we have the O for opposite and H for hypotenuse. O and H are with S, that stands for sine. So we're going to do the sine of theta. Theta is your angle, 18.4 equals the opposite side, which is 4, over the hypotenuse, which is X. Alright, so this is a little different than the last one. X is on the bottom, so hopefully you're able to figure it out. You can just multiply both sides by X and then divide to get X by itself. But a quick way to think about doing this is whenever X is on the bottom, you just swap it with this. Okay. Now essentially what you really would have to do is times both sides by X and get X sine of 18.4 equals 4. Then divide by sine of 18.4. Alright, and that will give you X by itself, and you divide that. But if you notice, all this right here really is taking 4 and dividing it by sine of 18.4 and swapping it with the X. Alright, so on your calculator, if you just hit 4, divided by sine of 18.4,
you've done enough. And some of you are doing more than
you get 12.67.
Core group is meeting now in room 311.
Alright, so 12.67 is the length of the ramp in feet. And we're done. Alright, so two situations on these. Either X is on top and you're dividing by the number, so you just multiply by it. Or if X is on the bottom, you just swap it with the trig function. The whole thing, just bring it over there and divide it. Okay. Alright, moving on, last kind of real world problem. You're 200 yards from a river. Rather than walking directly to the river, you walk 400 yards along a straight path to the river's edge. Find the acute angle between this path and the river's edge. So now we're trying to find the angle. Alright, so instead of the unknown being one of the side lengths, we don't know the angle. So let's draw a little picture. We got us a river here, and it says that we are somewhere right here, and we are 200 feet from the river's edge. Alright, but instead of walking directly to the river on that 200-yard path, we walk 400 yards along a straight path to the river's edge. So we're going to go out this way somewhere and go 400 yards along this path to the river. And they want to know the acute angle between this path that we walked and the river's edge. So this angle right here is our theta, the angle between the path we walked and the edge of the river. So we're going to do the same way, set everything up the same way we've been doing it. Our hypotenuse is the 400. And the side opposite the angle we're using is the opposite side. And of course the river's edge is the adjacent, so we're not using it. Which trig function uses opposite hypotenuse? That's sine. So this time we're going to hit sine of theta. We don't know the angle this time. It's the opposite, 200, over the hypotenuse, 400. All right, so sine of theta equals 200 over 400, which is just a half. Now to get sine to go away, all right, so this is something kind of new. We want to cancel sine. Okay, we want to, just like we, if it says plus 4, we do the opposite, we subtract 4. All right, so to cancel sine, you do what's called the arc sine. Arc sine is the inverse function for sine. Okay, just like multiply and divider inverses, square root and square root inverses. The inverse for sine is arc sine, and it's on your calculator. It's the sine raised to the -1. So what we're going to do to both sides is sine -1 to get theta by itself. If you do it to one side, you got to do it to the other side. Sorry, not sine, not arc sine of theta, arc sine of 1/2, right? So theta is going to equal whatever we get when we type in the arc sine of 1/2. So you hit second sine 1/2, and it gives you 30. And remember, our calculator is set in degrees, so it's going to give that to us in a degree measure. So that angle is 30 degrees that we walked. We walked a 30-degree angle right there on that path to the river's edge. All right, so you guys go ahead and try this last one, and we'll be done. So here is our picture that we got. We've got theta is our angle, 50-foot tall pole, and the pole or the zip line's hitting the ground 50 feet from the base of the pole. So the 50 on the pole is our opposite. It's opposite of our angle theta. And then the 50 along the ground is adjacent because, of course, the zip line itself is the hypotenuse. So the trig function we need to use is tangent, because tangent is opposite and adjacent. So the tangent of theta is going to be 50 over 50, opposite over adjacent. So we got the tangent theta equals 1. So to cancel tangent, right, we do arctangent. Right, when we do arctangent, it'll just cancel tangent, leave theta. So of course we got to do the arctangent of the other side of the equation. So on our calculator, we hit second tangent 1, and it gives us 45. So the answer is 45 degrees. This angle of elevation of the zip line is 45 degrees. All right, let me know if any of this is tough for you, if you need any help. And here's some practice problems you can work on, and just let me know if you have any questions.